Hello everyone, in the earlier video we have created a function that returns a list of image paths in different directories that are in the same root directory, and this time we are going to call this function get all files in another program rather than from which itself has been declared. So to create another program, let's go to File and click New File, and I'll remove these comments and going to preprocess.py. Let's select these three lines and copy this and go to this newly created file and paste it. And to save it, go to File and click Save. And let's name this program as main.py and click Save. And if you click Run, then it will give an error name get all files is not defined. And to use function declared in another program, you have to import it by writing from preprocess, which is the name of the program name, import all, and let's run again. And on the right side on your console, then you list the path of the images in the list all file paths. And the next step we will be doing is to convert this file path to the vector representation, and we can do it by calling image read from cv2, and to use cv2 we have to import cv2 up here, and let's pass the image path as an argument file path and store the returned vector in an identifier image. And if you look at the values in each image, then it will return numbers which are the pixel values in an image. And if you want to look at the shape, you can type image.shape. Then it will give different shapes for each image in the list all file paths. And we have to convert each image's shape to the same shape, and we can resize it by calling cv to the resize, pass the target image and pass the target size, and I'll resize it to 50 by 50 and store the resized image to image. And if you print the shape, now all the images are having the same shape. And the next step, we will have to store all the images in a list, and let's call it trainx, and let's store these images to trainx list. And after you have added all the images by printing the shape, let's look at the shape of the list. And actually list object does not have the attribute shape, so we'll have to convert it to an array. And another reason for converting the data type list to the array is because when we pass the train data to the model, the model can only understand array data types, so we have to convert every training data to array data type. And to convert it, we need to import numpy, and let's use alias mp for abbreviation, and convert trainx to array mp.array trainx. And if you see the result, then it'll show shape 77 by 50 by 50 by 3. 77 is the number of the total number of training data images. And if you see the line reloaded modules preprocess, and to remove this error line, you can go to Tools and click Preferences. And when the preferences prompt pops up, then you can go to Python interpreter. Then on down here, if you see enable UMR, then deselect it and click apply and click OK. Then close this tab, and when new tab pops up, you can see the result by clicking the run, and this time the error line has gone. And let's look at the value in trainx, and it will return a list containing the vector representations of the corresponding images. And anyhow, we cannot pass this value, and before we pass this value to the input layer, we have to normalize it. And normalization means that we are going to convert each value in the data that is scales from 0 to 1. And the reason we are rescaling the range is because when we do training process, the normalized data distribution will train faster and converge faster. So to rescale it, that it ranges from 0 to 1, is that we have to divide it by 255, because 255 is the maximum value that an image can have, because each pixel value ranges from 0 to 255. So let's divide it by 255, train x by divide 255.0. And here what you have to bear in mind is that you have to divide each pixel value with floating point number. And the reason is that there's a process called backpropagation, which is in the training process. Then when it updates the weights and by doing gradient descent, and if the integers are passed, the integers are not differentiable. So to be able to differentiate the values, they have to be converted to floating point numbers. So you have to convert each value to floating point number. And if you look at the normalized value, let's see the result, and you can see the pixel values normalized to 0 to 1. It scales from 0 to 1. And up to here, we have prepared our training data per images. And I want to finish up here, and I hope to see you in the next video. And thanks for listening. Bye.